Hello everyone, it's February 25th. Alright, a bit late, but let's try this. Greatest common divisor traversal. You're given a zero indexed integer. Well, first of all, the passing rate is 25.6%. That's probably one of the lowest, right? It's definitely one of the lowest I've ever seen. Alright, you're given a zero integer, right? And you're allowed to traverse between its indices. You can traverse between index I and index j, and I is not equal to j. If and only if the GCD is larger than 1. So only if they are not coprime. Your task is to determine if for every pair of indices I and j, every pair, right, I and j in nums, where I smaller than j, there exists a sequence of traversals that can take us from I to j. Return true if it is possible, or false otherwise. So every single pair. So based on whatever it is, we can create a graph. So the question is, can we go from any node to the other node, which just means, is the graph connected? Right? That's the question. Is the graph connected? Okay. You can traverse between two indices, I and j, if and only if they are coprime. They're not coprime. And your task is determining if for every pair there exists a sequence of traversal that can take. Yeah, isn't that just ask if it's connected? Like if the entire thing is connected. Why is it difficult? Is it the process of finding? Oh, it's the process of finding to produce the graph, right? Is that a difficult part? To find a graph? Huh. I mean, ideally, if you want to find the graph, it runs O(n) squared, because you have to find every single pair, right? You find every single pair to produce the graph, and then you have to decide if the graph is connected. Well, you can't do that, right? You cannot do that because it's not. It is not possible to do O(n) squared, right? So I'm thinking about maybe we can union find. Union find is an easy way to decide whether a graph is connected. Probably in this case without having to go find out the entire graph. So how would you approach it? Well, I mean, essentially, is how can you make sure that there is. I wonder whether it will be faster to simply, factor every number. What do you think? We factor every number. How long does it take to factor a number? Well, you divide by 2 with however many times you need, at most like 30 times. And actually, no, it's a 10 to the 5th, so it's not even 30 times. You should do that, and then you do 3, and then you do 5, and then. But the thing is, you don't know it. Like if it's a prime number, if it's a prime number, then if there exists a prime number, a big prime number, then how do you know it's a prime number, right? I mean, technically, you can just keep looking for, but I wonder if factoring is a good way to go. If you don't factor, then you have to. Yeah, that's the problem. I'm looking at number 3, right? Example number 3. Actually, example number 1 is also a good example. Like 2, 3 is co-prime, so they cannot, at least on this current step. But then 2, 6 is, and then you have to do 3, 6, right? That's what you have to do. Huh. Every pair, yeah. And we only answer true or false, right? So the target is not to really figure out all the traversals, right? We don't really care about the traversal. What we care about is whether all the numbers can be included. And all the numbers can be included just means, some stuff. Now what we need to find is if there exists a number that does not belong to any of the others, that does not have. That's actually not true because I can have, 2, 4 and 3, 9, right? If you go 2, 4 and 3, 9, that's a false because yeah, that's that's a false because 2 doesn't belong to 3 and 9, but 2 does belong with 4. That's a slightly, different situation. That is very interesting. Yeah, you can't just. Yeah, I'm still thinking about the factorization part. I mean, the factorization part, each number need to factor it. How can you do factor fast? I fear it's gonna time out if I try to factor. Because I don't have a good way. And 10 to the 5th, there's still a lot of prime numbers, right? To 10 to the 5th. A lot. Like maybe hundreds of prime numbers. And I don't think it's wise to, do the sieve. You try to sieve them out. That's gonna take time, right? That's gonna take time to find them out. And if you don't do it, you just try, go through all the even numbers, right? That's kind of the way we do. And yeah, we try to take as much as those out, and then yeah, we can factor every number, but I just don't know how long it's gonna take if we try to factor every number. I mean, the point is not really factor. I mean, like 10 to the 5th, if you want to factor, you just divide by 2. You just keep dividing, keep dividing, keep dividing. Five times. So maybe it won't get too many times, right? Maybe it won't get too many times. But when do we know that yeah, if the value it try to divide is more than its QRT, right? If it's more than its QRT, then we call it. Then we know that is okay. So let's say you factor everyone. Okay, you factor every number. So each number, once you factor, it belongs to one of those. I mean, we haven't even really solved it, right? All we know, if you factor it, is, say, everyone have factor 2, we have a list of numbers. Factor 3, we have a list of numbers. Factor 5, we have a list of numbers. So you do that. Right, you do that, and then these belong together, right? I mean, okay, so in this case, we can do union find, right? Everything that here, these can be unioned. Everything that's here, we can be unioned. Everything that's here can be unioned. Okay. Let's try this. Since it's going to be a union find solution, which means I need to write union find. I think I read union find yesterday, so hopefully I still remember how to do union find. Okay, let's do union find first. Union find class DSU. That's what I remember. Def initiate self. Union find is there's n, right? Yeah, the total members, so n. And this is we don't return anything, so self.parent, okay, equals to list range n, right? And self.rank is equal to 0 times n. Okay, so def find first. So I want to find a parent of this integer. We say if self.parent x is not equal to x, then self.parent x shall equal to self.find self.parent x. Okay, and then eventually we say return self.parent x. Okay, now that's find. Next is union. We union x and y. Okay, and this will return. Usually I return a Boolean value. That's what I like. And then we say parent x, parent y, self.find x and self.find y. And then if px is equal to py, then we just return. You know what? Let's not return this Boolean. I don't think I would use this Boolean at all, right? So it just returns. So they are already unioned because their parents are the same. Otherwise, then we say if self.rank px is larger than self.rank py, right? In that case, we say self.parent py shall equal to px. Right? I think it's to set the, yeah, so we say px is going to be the parent. So self.parent py is equal to px. Okay, and that's fine. Elif self.rank, if px is smaller than self.rank py, so in that case self.parent px shall equal to py. Otherwise they're equal, then self.parent self.rank px plus equal 1 and self.parent py will equal to px. Okay, I think that is union fine. And for this function, for this solution, I need another function which is called which is called factor, right? We need to factor it. But then I realized another thing, because when you union, it's always have to union two things, right? You have to union two things. Oh, that's fine. That's fine. I know what to do. I know what to do. Yeah. So yeah, we union everything, and then they all have a parent, and now I just go check the parent. Okay, yeah, that's fine. So what we need to do is def a factor function, right? So we're given an n, and we need to factor it. Oh, factor it. So what do you return? I need to return a list, right? A list of its prime factors. That's what this function do. And yeah, so we're going to return a list of integers, which is the factor. Okay, so how I'm going to do here is trying to factor this number. Now we're going to start with 2, then we're going to go to 3, right? Then we just say while n and, right, n mod 2 is equal to 0, then because I need to record. Okay, I need to record. So rest equal to this, right? And what do I do here? I need to have true or false, right? Okay. I just said factored equals false. Okay. So every time we do this, we say factored will equal to true. And n2. And then we say if factored, then rest dot append 2. Alright, so this handle 2. Then we say f is equal to 3. Alright, now we say f is equal to 3. And then we say while f times f is smaller or equal to, f times f is smaller or equal to n, okay, then we say factors is equal to false. And then what? Then we say while n and n mod f is equal to 0, n divided equal to f. Of course, we're going to set factors equal to. Oh, I think I have an easier solution. I can just say if res minus 1 is not equal to 2, then res dot append 2, right? Then I don't need this. I don't need this, and f, and I don't need this. Same thing. I can just say if res minus 1 is not equal to f, then res dot append f. Now divided this. Now we try it again until we get out. Right, and now when we get out, we'll say f plus equal to 2. Right, so we come back up, and then we check, and then we keep going until we finish. Then we will return the rest. Okay, so that is everything. And then we're gonna say dsu equal to dsu numbers. we can do the maximum number, so we don't have to go through the whole thing. So we do 10 to the 5th, right? 10 to the 5th. Actually, it should be 10 to the 5th plus 1, because I need to handle 1 to 10 to the 5th, right? Oh, but then I have to go through 10 to the 5th every single time. Damn you, man. Max n. Let's get a max out. So, and this one will be max n plus 1. All right, that's my DSU. And then what we need to do is, and 0 is not included, which is fine, right? 0 is not included. And now we say for any nums, okay, for each any nums, then we say for factor. But I need to know the origin value that has this, right? So I need to have also a dictionary to say to hold the value that has it as its factor, right? Because otherwise it's not going to work. Because you union, you need to find 2 values to union, right? Even to find 2 values to union. So we can seeds, okay? Seeds. Then we say for f in self.factor n, and we should not do n and what if it's a 2? Yeah, that's fine, right? And one will not be this, because I will handle it here. But hold a second. What if n is if n is 5? This doesn't run. Okay, so we try 3. And then go out, right? I mean, 2 it works, right? If n is equal to 2, I will put a 2 in, and yeah, get out. Yeah, and the 2 is fine. It's just at the end, if return res, if res else, yeah, this is when it itself is a prime number. Because you put 7, 5 in it, it won't go through any of those things. Like put 7 in it, or you put like a big prime number, right? We don't go through this, then we go through this, but it doesn't work. So we plus 2, plus 2, plus 2, plus 2. Yeah, so the fear is we get a giant prime number in nums, right? We get a giant prime number, and you have to go through a lot of steps just to factor it. That is what I fear, right? I think that's going to take the longest time. But at most, because it's f times f, right? So if we go 10 to the 5th, and if we SQRT this, it's only 307. It's only 316. At most, it's 316, and divide by 2, so 180 times. I mean 150 times, right? At most is 150 times. So I think it's fine. Okay. All right. So we will factor it, and then for each this factor, we can say if f not in seeds, then seeds f will equal to n. Then we don't do anything, right? We don't do anything. Else, if f is in seeds, right, then we say DSU, the union, union whatever is in the seeds, right? Whatever is in the seed for the current f, and remember we can union with 0 though. Seriously, right? We can union with 0 because 0 doesn't belong to anything. We can union with 0. And then everybody can union them. We'll still be fine, right? We'll still be fine. And eventually we go from 0, right? We go from 0 and then just try to see try to see how many groups, right? How many groups there are. That's exactly what we want to see, how many groups there are. So I think I can group with 0, but because it's fine, which means I can just, I don't need this. Oh, I do need this. Do I need this? Then it can just be a set, right? Doesn't have to be a map. It can just be a set. Right? It can just be a set. No, I don't think so. I think it needs different seeds. So yeah, we set the seed, otherwise we'll union the seed with the current n. Okay, so we'll go through this whole thing, and once we go through this whole thing, I'll go through the DSU, and then we can say the num groups. Okay, groups can be a set, and then we just say for. We have to go through everything in the DSU. So for, it's called n, for I in range 1 to max n plus 1, right? This is how we're going to go through. Actually, no, we should go through, my bad. Let's actually just go through the whole thing. That will be fine. For n in nums, right, everything. And what we're gonna do is we'll find it. So we'll say groups dot add DSU dot find n, right? And at the end we'll return lang groups shall equal to 1. If it's equal to 1, that means everybody can be grouped in 1, otherwise we don't. Okay, we need to annotate this, which is fine. This is going to be a list of integers. Okay, 22. So take a look, see if this one works. Throw away these. Damn it. Okay, if not, res or, yeah, the same thing. If not, res or, yeah, didn't realize. Invalid. Oh, my bad. Of course, that's, yeah. It's or. All right, how about this one? Damn, that was pretty bad. Okay, so we had a rough patch. That's all right. I still believe in this method. We just need to figure out what went wrong. And we have a debugger. Yesterday we used a debugger and it works pretty well. So I'm gonna debug this one as well. So we have a 236. Simple. Okay, should be true. Just need to figure out why this one doesn't work. We should have input is n, and input is nums. So what is it called? It's function. Function is called can traverse, right? And we're gonna do nums. Okay, and what we need to do is get a. I can put, let's put this one here, okay? And let's debug this one. Debug this baby. Yeah, I need to figure out how to force it to be like bigger. All right, anyway, I'm here, so I need to step into. I think this is step into. Actually, I don't need to step into. but I need to know the seeds. That's fine. Oh, this is step into. Okay, so I'm gonna step out. Wait, I cannot step out. This is step out. All right. Okay, so n equal to 2 because, okay, that's fine. Number is this, seeds is nothing, and max n is 6. And that's not what I had in mind. Step over. Oh yeah, the step over. Okay, step over. What's f? F is 2. Okay, that's fine. Step over. So f is 2. Number is 236. Seeds has nothing. DSU, that's fine. So f is not in seed. No, f is not in seed. So seed, okay, we grab the seeds. That's fine. And oh, I see the problem. So we have 2 is on 2, 3 is on 3, and then 6 will merge with 3, but 6 does not merge with 2. Good point. Yeah. So when 6 comes out, no, 6 comes out, I'll have 2 factors, so I go through every single factor. Anyway, let's just keep going. So this is seeds is done. Next f, now f, the next n is 3. F is 3, and then we'll do this. That's done. Nothing. Next n is 6. F is 2, so we do this. So we'll be union 6 and 2, right? Union 6 and 2. Next f is, oh, 3 was not. 3 did not get, so there's something wrong with the factor. Okay, so 6 comes in. 6, we done this. So we put 2 in. Now we have 3 left. And 3 doesn't work, so it's 3. And it's 3 times 3 is nothing. Then we get out. And we shall, ooh, that is a good thing. So while n is equal to, right, we do this and then divided. But whatever it is, right, if it gets out, whatever n is, it should be included, unless n is equal to 1, right? Unless n is equal to 1, but can n even be 1? N can be 1, right? N is 1, then it will not equal, and then we get out. So yeah, unless n is equal to 1. Okay, so this is actually not right. We should say if n is not equal to 1, then res.append n. Okay, then we can return res. And I handle the other case as well. It's like when you 3 put it in, right? And yeah. Okay, so let's do this. 25. Okay, this one pass. Let's try 11. J, no, 22. Okay. All right, run again. All right, looks good. For these, I have some other test case I thought about. 2, 4, 3, 9. That's a good test case, right? One number by itself, and 1, 2, 3, 4. 1, 2, 4, 8. These are all good test cases. I can also do a 2 for 8. Okay. That does look okay. Yeah, like a 2 for 8. I should do that. And what else? that you can think of. We can say, 2, 3, 5, 2, 3, 5, 7, and we multiply them together. 210, right? That should be a true. Let's see if this one can get this to be a true. Looks promising. We'll give it a shot. I'm gonna write some stuff down. Maybe this one will be correct. 2709, right? I will say factor each number, right? Each number to find its prime factors, and then use union find to decide whether all the numbers in n in nums can form a connected graph, something like that. All right, let's give it a shot. Let's see if it works. Oh, uniques. Damn it. Forgot about the uniques. Shoot. What do you say? We forgot about uniques. I will. I will do this, and nums equal to a set of nums. That is unique. Does this work? I don't understand. I have one. Wait, hold on. 1 is false, right? Oh, wait, what? I cannot do unique. Oh, shoot. That is... Wait, hold on. Yeah. It should be indices. It should not be the numbers. Damn. So it should be in enumerate. Okay, it was my bad. And then this is fine, but this we should do I. Right? Otherwise it should be I. And this is the same thing. Oh, this is on me. I completely misunderstood this. It should be indices. So again, in enumerate. Actually, you don't even need n, right? So this can be just underscore, because I just need to find I. Okay, let's see. Oh, I completely forgot about the duplicates. Okay, I forgot about the duplicates. If I forgot about it, should be indices. All right, not too bad, but well, we got this. All right, we got this. So it's definitely not a bad result. It's actually much better than I had expected. It's just slow, but I don't really think it's slow. There must be a difference in the test case. This is today's. This is from 2023, 6 months ago, 5 months ago, 6 months ago, and we have 925 test cases. We have 925 test cases. But why the difference is so big? Oh, that's why. That's why, yeah, we use union find. It's exactly the same thing. I have a count function, huh? Wait, no, wait, hold on. This is DC, DSU. Do I have a count? Ooh, that was smart. Number of elements in each group. Ah, very smart. And in this case, I just go through this primes list. So it's the same idea, right? It's the same idea. Yep. Same idea. It's just slower, but yeah, it's okay. Right, it's okay. I think I was using... Yeah, this is exactly the same, and I have to do this. I pull down all the prime factors. You can, right? You can. It's nothing stopping you from doing it. But what I want to do is update the union so that instead of rank, I will do a count. Okay? Count, we say this is the number, right? The number of elements in each group, right? This is defined, and here the count. Yeah, so okay, so first of all the rank %s, all the rank will turn into count. Okay, and then, but after we do the parent thing, we have to update the count. Self.count px plus equal to self.count py, right? It's the same thing. Self.count py plus equal to self.count px, and in this case, isn't this the same as this one? Right, so I can probably just say if this count is larger or equal to, I simply do this. Right? So I can remove this, and this can be else. Yep, that's true. So I can say C T this. Okay, and then this is fine. We keep this, and also update, right? Use count to obtain the number of elements in each group in DSU. And I think everything's the same, but except at the end, right, what we need to do is just return self.count, not self.count, DSU dot count self dot, not D, whenever you say self, DSU dot find 0. Right, so we can do DJ. We don't need this. Incompatible value, got int, expected boolean value is equal to landnums. Okay, okie dokie, let's go up, go to 30, and then do this. We select the whole thing, and let's go here. Actually, maybe it will be better we just do it this way, and that'll be easier for me just slide. Okay, again, we're gonna try all this, see how it goes. That was very disappointing because for whatever reason it was not working. Everybody's false. God. Why? It must be something's wrong here. It's not adding the... Oh, maybe I think I should start with 1, right? Because it's the number of elements in each group. We should start with 1. Number of elements in each group is start with 1. And then we use this. I hope it's a little bit faster. But the dominant factor will be this function. So yeah, it won't be too much better, but yeah, it's definitely okay. It's definitely okay. We can actually add a new line, right? Of course. No, don't say of course. That's not what I was trying to say. What I was trying to say is the slowest part of the algorithm is the factor function. We can speed up significantly, right? If we hard code all the prime numbers, right? Prime numbers smaller or equal to 316, right? 316 because its square is, because it is the smallest number. It is the smallest number. No, it is the biggest number. It is the biggest number whose square is not bigger than the max possible value in nums. This list is not that big, so it's not that big. And with the prime list, factor can run much faster. From my own solution 6 months ago, with a list of prime numbers, right? The run time is, I think, what, like half? More than twice, right? More than twice as fast as today's solution. But I am not going to implement this because I don't have the Ghana. I'd rather just, call it a day. It was a good day. Yeah, it was a good day. But we can just take a look how they solve it. DSU as well. It's sieving it. I think this is just a sieve. Yeah, I think this is just a sieve. Yeah, I think this is just a sieve to get the right. This is the sieve, and then we start with 2 plus plus max, this is just the number, right? And then we go through the sieve, and we say if it's equal to 0, then this is a, yeah, this is just set it to false. Yeah, this basically give you all the prime numbers, right? This is sieve of Eratosthenes, right? You give a sieve to produce all the prime numbers, and once you produce the prime numbers, you go through this. I think this is what is this? For each vowel, vowel equals 0. Oh yeah, we obtain the current prime, right? We obtain a current prime, and root is this. Okay, so union of find, and we will merge it, and while this is equal to 0, this will get the that's not just a sieve. I think this is a sign. This is going to be the prime number. So this is assign a prime factor to it, right? This is basically just assign a prime factor to the number, to the sieve number. So when I get this, I obtain one of its prime factor. Doesn't matter which one. So we obtain one of the prime factor, and then we try to see if it's in it. If this prime factor, yes, right? If this prime factor is have not been associated, now I associate the prime factor to this number, which is understandable, right? Which is understandable, and then I'll reduce this, and I will go back up, right? So, and then we get another prime factor for the next value. So yeah, so it just goes through the same thing, and to build up the union find, and at the end we do this. So yeah, exactly. The only thing that can make this faster is to create a list of primes, but I don't want to do it today, so I'll just let it pass, right? I'll let it pass. The basic method is the same. Okay, yeah, that'll be it. Oh, people don't like this at all. I mean, I don't know why people don't like it. It is the same solution. Okay, yeah, that's it. I have no intention to continue, but again, 2 hard problems in a row. I haven't done this for a while. I mean, this is not really the hardest out there. You know what? I feel a little bit desire. Yeah, I feel a bit desire. Maybe we can do one. Definitely not this one, because we've done this one already, and the whole purpose of doing this, I just want to do this one more time, and I want to do this not using, I think this is the BFS. No, this is the, yeah, this is the BFS. The BFS will stop. I don't like it. I'm not that I don't like it. I can definitely do it. I'll do the Dijkstra, right? So this one, I want to try the Dijkstra, and I want to try the Bellman-Ford. And we probably can do, oh yeah, this is circular. We haven't solved this one yet. We should try the circular array. We have an idea, right? So basically this question is, you're given this, and for every index I, you can replace a number with either yourself, or the one to your left, or the one to your right, and you can wrap around, and asking what is the minimum number of seconds need to take this. So my solution, I already have a solution, is to go through the thing. For each number, you're gonna have a gap, right? For each number, you will have a gap, and because they wrap around, so if you are a single one, then your gap is this entire thing. So what we want to find is a maximum gap for each number, and the answer will be the smallest value of all the maximum gap, and then divide by 2. Okay, that was my solution. So I didn't find time to implement this, but maybe I can implement this in, like, 5 minutes. We'll see if we can do so. So the way to find the maximum gap will be, I will create the first position. I need the first position of this, and I need another thing which is called the gap, right? So it's like two arrays. Okay, we have 2 arrays. Oh, do you want arrays? Or do you want hash map for this? I mean, arrays can... No, I want hash map. I'm gonna use hash map for the first occurrence and a hash map for the smallest, no, for the biggest of the gap. And then I'll just go through the whole thing. And each time I go through, I need to update. Oh yeah, I need to update. So no, I need 3. Damn it. I need 3 hash map. Oh, Lord. How we do not like 3 hash map. No, don't do 3 hash map. 1 hash map. 1 hash map, you will store a list. You will store an array of size 3. So each value you can control what they are. The first value will be the first occurrence of a of the stuff. The second value will be the the maximum count of the difference, right? The gap. And no, the second one will be the previous index, and the third one will be the gap, right? And then we just keep going. And at the end, if you, yeah, okay. So let's give this a shot. 5 minutes might be pushing it, but maybe we can. Do maybe like saying I don't know. This what's numbers 2a. Maybe we can do this in 10 minutes. And we'll do Java for this. Okay. All right. Do you still remember how the problem goes? Yeah, I do. I think I do remember how the problem goes. So what we need is a hash map. So we call a map of integer and an int, right? What do you call it? We call it call a map. I don't have a good name for this. All right, we're gonna do a hash map. And then what we're gonna do is for int I0. Yeah, I need the index I smaller than nums dot size I plus plus. Okay, perfect. And then what we need is its value, right? So we say map dot put if no map dot add. Wait, what happened? Why? There's a hash map, right? Dot. Huh? Is that what? I don't understand. I do not understand why this one's wrong. Hash map is not. I don't know. Maybe map is a thing we cannot use. Oh, I cannot. I can't use it. Wait. Wait. Hold a second. What the hell is happening? Why I cannot do map dot add if. I don't know. Something is not right. Am I hallucinating on this? Am I hallucinating? Java map add if they don't have this put. My God, you are wrong. It's not add. It's put. But I don't have this put function. Wait, what? What is wrong? Yeah, it's put if absent, right? Hash map. Or I cannot put int in this. Really? Can I put? I actually don't know. I need to run this, but I don't know how to run this, honestly. So I'm gonna do JShell. So I say is map integer and int. We say map equals new hash map. Okay, probably this will have to less. Yes, map dot put if absent 1 new int 1 2 3. I can do this. Yeah, it's something is not right. Okay, something is very wrong. I don't know how to resolve this. It's not num project file, only syntax error reported. I think that was the problem. That was the problem. But how the other, I did the other Java files and then it works. Oh, because you are not in a folder. Is that why you're not in a folder? Hold on. Yep. See, these work. No, this also doesn't work. It says num project. But I get syntax highlight here, and I get the. Yeah, I got it here. All right, this is a NeoVim problem. It's my setup problem. Then how do I resolve it? How do I resolve it? Project file. Okay, so what if I put this in a folder? What type of folder do you want? I can say make directory that would be so stupid though. So you're saying I'll make a directory called this. And I will move this. Okay, I'll move this inside this directory. Okay, and then I will NeoVim this thing. 2808. Okay, let's see if this one gives me the syntax highlight. No, it still doesn't give me. Huh? How do I solve this? It says it's a num project, but it works before. That's the thing, it works before. Right? I don't understand is it works before. I have like all these files. Right? I have all these files. Like this file. It's also a num project file. It says only syntax error reported, but I got way more than just syntax error. Okay, let's just try it here. If I do a map integer right? I do int, say map equal to new hash map, and if I do map dot, yeah, I got everything, right? I got put, I got get. What the hell is happening? Seriously, what the hell is happening? Why the other one doesn't work? I need to Google this. I do not understand. Right? I do not understand. I have class solution. Everything is the same. Right? Everything is the same. Alright, it's a num-project file. Only thing is num-project file. Okay, so it's gonna be neovim java is a non-project file. Only syntax are recorded. Maybe take a look here first. Did you update, or did the Maven get update? You try to follow the steps, troubleshooting. Clean and then restart neovim. Clean and then restart? I don't have Gradle, I don't have Maven, I don't have any build tools for this. This does not solve my problem. Let's try Reddit. Doesn't really say anything. My God. One of the files is in this. Yes. But the thing is, it works on some file, but doesn't work on the other file. Interesting. So suppose I shouldn't work. I don't know. Yeah, you use Palm. Yeah, people are developing this in. Cleaning. Command Shift P. No, that's not. Not a direct project folder, but a parent folder. Okay, I still don't know, but I can give a few shots. I can try. So let me verify one more time. Like we don't have But the thing is, we have these. These are some Java stuff. Right? These are some Java stuff. It's just here I don't get the syntax highlighter. Not syntax highlighter, the other thing I need. I mean, do I even need it? Right? Maybe I can just say, screw it. We don't need this. You know what? I rather go for we don't need it. I'll just. It doesn't have syntax highlight. Not syntax. It doesn't have the thing I need. Screw it. Put. I know it's put if absent. I'll do it. I'll put if absent, which is nums I, right? And new int. So the first one is the occurrence, right? First occurrence, the previous occurrence, previous occurrence. That is interesting. And I need to previous occurrence. Yeah, we should do I, right? And then count. Count is 0, the gap, right? We don't have a gap. And then we can say map dot put nums. Oh no, not put. Get, right? Get nums I. This is give us the int, and we shall say the current minus the previous will be a value. So we should say the current gap, right? Current gap. You know what? This doesn't feel good to me. I'll do a if. Okay, we say if map dot contains. Oh yeah, this is no syntax highlighting. It's really annoying. Map contains contain keys, right? Contains keys. Yeah, contains keys. So if this contains key, I have to resolve this. This is not working. Okay, I have another solution on my sleeve. What if I move this one, okay, inside the folder that I know in the past works, okay? Then I do this, and I just put this out. It will still tell me that it's a non-project file, but maybe I get the syntax highlighting here. Dot. No. For whatever reason, it does not work here. Okay. I mean, I guess it's... Is it the file name? Is it just the file name? I'm just throwing stuff. I'm throwing stuff at this, and hopefully I get some out of it. Okay, so I know I can do 2024 02. I do 30. Okay, because it's just, you know, it will work. 02. No, you know what? I will do this. SK SF 2024 02 30, which should just be this one. Well, it's gonna pop out. And let me see. I do this map dot. Yeah, still not. I don't know. It just doesn't work. Right? It just doesn't work. Interesting. It works before. It works before. I don't know. Hash map. Yeah, just. I don't understand. Honestly, I have no clue. Like, I do this. I do full. And full dot. Yeah, it still just doesn't work. Forgive me. I do not understand what happened. I think I will just it's okay. I'm okay with it. Okay, I'm okay with it. I'll just roll it. It's not gonna be a good experience, but so be it. All right, we say contains keys, nums I, right? So I say if it contains the key, I'll do some stuff. If it does not contain the key, I'll do some stuff. So this will be if it does not contain a key, right? If it does not contain a key, I'll do this. I just put, it doesn't have to be absent. I'll put this. If it contains the key, then I can say int gap, right? Current gap is gonna be I 0, 1, 2, 3. So I minus map.get nums I 0, 1. That's the previous index. And I need to minus 1. That's the number of elements in between the two, right? So we have the gap, and we shall say map.get nums I. We probably can simplify it. So we say gap G, right? G equal to map.get nums I, okay? And I don't need to go through this again. This is going to be G, right? And then this is the same thing. We can say G2, which is the gap, right? The gap length. So we say G2 shall equal to math.maximum G2 and the gap, which I think I can just simplify it by remove this and coming here, and then we paste here. Okay, so I did basically, I get the new gap because I need to maximize the gap. And after I maximize the gap, I say G, I forgot this, right? I say, wait, what the hell? The type of the expression must be an array type, but it is resolved to list integer. Oh, nums is a list integer. Oh, is that why? I made a mistake. No, I don't think so. But anyway, this is wrong. This should be get I, right? Yeah, this is get I. And this is also, I thought num is a, okay, my bad. Nums, this is also get I. I don't know why I have this one. All right, so G2 and then G1. We shall say the array, right, is, what is the array? The number, not the number, first occurrence, right? First occurrence index, previous occurrence index, and maximum gap between any consecutive two occurrences. Okay, so G2 is the gap, G1 shall be the occurrence is 1. Okay, otherwise we do this. So blah blah blah, once we get to the end, right, we have everything, we get to the end. Then I need to go through this one more time to find anything that has gap 0, right? If your gap is 0, that means your gap is the total length minus 1. Okay, and then we'll go through this, we'll find the smallest gap. Okay, so we say int min gap is equal to nums.length.size, right? And then I say for, I go through the map, right? Go through the map. Int G of map dot value set. I don't know. Map values. Okay, so it's values. Okay, so for all that, I say a min gap shall equal to math dot minimum min gap, and G2 is this equal to 0? If it's equal to 0, that's the only occurrence, then it's gonna be nums dot size minus 1. If it's not, that's gonna be G2. Yep, we go through this, and at the end we return min gap divided by 2. Okay, so that's kind of my solution. Might have syntax error, but give it a shot. That's my test case. Okay, that's my test case. I use everybody's. I use this. Just, you know, see if it was correct. Cannot find symbol. Oh, I know why the syntax highlighting doesn't work. Dude, my dear dude. I don't know what to say, man. I do not know what to say. This is so stupid. I am rendered out of words. So it's has nothing to do with Java stuff. It's because I mistyped some stuff. Ooh, it's not right. Okay, I'll put surprising. My output is 0, supposed to be 1. Oh yeah, I know. It's the gap. Have to, if I remember, I think I have to plus 1, right? I think it has to plus 1 divided by 2. So if it's even, if it's odd number, like if I have 3, then it takes 2 steps. Yeah, it takes 2 steps. Okay, let's try this. Okay, I got correct on some of them. Which one is wrong? The last one, not the last one. The one before the last. Ooh, the one before the last. This, dude, how did you get this one wrong? Ah, because it's all 0. That's fine. That is okay. Why do you say that's okay? Because I need to set a -1. If I set it -1, that's a flag showing that it has never been handled, right? So in this case, I meet another one and then I can get back to 0. So I shall just say if this is equal to -1. If it's -1, that is the first time. It's the only occurrence. Oh. So now I got a different value wrong. Okay. Oh yeah, you didn't do the other thing. You're setting it in check. Yep. I forgot to do another thing because at the end I need to check the wraparound. It didn't check the wraparound. Right? We did not check the wraparound. I'm not sure if that's spot. I need to check the wraparound. Yeah, I need to check the wraparound. So the min gap. So if this is fine, but this shouldn't be G2. This should be the maximum. Okay, so here is the thing. This should be the maximum of G2, and the wraparound is gonna be G1. Okay. Oh, hold on. That G1 is the last occurrence. G0 is the first occurrence. I need to find whatever is towards their end. So it's gonna be nums dot size, okay, minus g1, minus 1, right? Minus 1. So it'll be this minus 1 plus g0. Okay, g0. So that's the other one. Like, run it. Yeah. Okay, so I need to put another the gap when g2 is equal to minus 1. That means, okay, that means the number only occurs once in nums. We also need to use g0 and g1 to compute the wrap around gap. Okay, so now I think I'm confident. I'm gonna write some stuff here. Find the max gap, including wrap around gap, between each pair of identical numbers. For those numbers that occur only once, its gap is the length of nums minus 1. The answer is the minimum of these max gap plus 1. The answer needs to use the number, right, that has the minimum of these max gap. Call it ON? I think it's ON. All right, so hopefully it's correct. It is correct, so that was good. The solution works, and I can call it a day. Call it a day, man. What an eventful day. It's a good day. Okay, I did not have planned to do this, but it turns out to be pretty good, right? Turns out to be pretty good. Maximum gap, yeah, I think we're talking about the same thing. Okay, that will be it, right? That will be it. Thank you for all who has tuned in, and I'll see you guys tomorrow. Adios.